Welcome to the future. I'm Mark Sackler. This is Seeking Delphi number 7, Additive Manufacturing. We are what we print. By now, just about everyone has heard of additive manufacturing, better known as 3D printing. It's been around for about 30 years now, but has not progressed as quickly as our electronics-based information technologies. As the information age has turned everything digital, our physical world has remained stubbornly analog. Is it even possible to make that digital transformation in the world of things? Well, in a way it is. With additive manufacturing, items are built one layer at a time, material printed on top of material by 3D printers programmed with software-enabled designs. But it seemed at times that the slow progress of the technology might limit its potential scope and uses. No longer, because it isn't just for small parts and doodads anymore. It's scaling upwards and outwards to print larger and more complex things, including food, body parts, and even entire homes. Dr. Paul Tinari has been front and center of this manufacturing revolution almost since its start. And he's currently engaged in a project of a scope that would have seemed impossible just a few years ago. I spoke to him recently. Here's what he had to say. I'm speaking with Dr. Paul Tinari. He's the Chief Technical Officer and co-founder of Joom3D.com Technologies Incorporated and author of The Joom Destiny, Just on Order Making. Paul, welcome to Seeking Delphi.
It's a great pleasure to be talking with you.
Paul, give us a little bit of your personal background, how you got to where you are right now. Who is Paul Tinari?
Well, very briefly, I was actually born within sight of Yale University in New Haven, Connecticut. American, Italian father, French-Canadian mother. My father died when I was 5, so my mother migrated back to Montreal, Quebec, where I grew up. And from a very early age, I had an interest in technologies. I was always, for example, in the sandbox, building highways and bridges and so on. So my mother saw I really wanted to be an engineer. In grade 7, I designed what today would be called a hybrid vehicle that used an electric motor with a gasoline engine to recharge the batteries, and it had photovoltaic cells on the roof. And the response of the physics teacher when I showed this to him was to have an entire physics class devoted to ridiculing the idea, because he said the solar cells alone would cost $10 million, which at that time they would have. Anyway, so it made me not want to share my ideas with anyone. So you can see how ridiculing a child can have a lifelong effect. Anyway, so I did a degree in engineering physics at Queen's University in Kingston, Ontario, Canada. And I did a master's in solar engineering, and I did a PhD in fluid mechanics. So I've covered pretty well all the bases of alternate energy and advanced technology. I've worked as a consultant for the U.S. Navy for a number of years. I helped introduce the concept of 3D printing to the Navy because they were suffering from a spare parts problem. They would go to sea in a naval task force with 20 million spare parts, and the lack of a single spare part could threaten the entire mission. So I thought this was ridiculous, and I said, well, there's a new technology called 3D printing, which allow you to manufacture your own parts at sea. And so they put their heads together and started developing their own proprietary 3D printers. And they now manufacture all their parts at sea, and many of the other branches of the military doing this as well. So, for example, Marine units now bring a 3D printer so they can manufacture everything from new buckles for their packs and new ammunition when they're in the field. So it's spreading very, very rapidly, and I was one of the first people to see that it was far more than a technology. Like the steam engine, it was going to have very strong impacts on society. And so the book, The Joom Destiny, just on order manufacturing is the name I give it. I give it because you can manufacture anything, anytime, anywhere, when you need it. I wrote a book that was the first book to not just study the technology, but to look at the impacts of the technology. So, for example, very soon it'll be possible to manufacture electric vehicles far cheaper than any of the ones offered by the big three auto manufacturers. So, for example, you could manufacture an electric vehicle for $4,000 or $5,000, and these vehicles instantly make a whole bunch of industries obsolete. So they don't need spark plugs, they don't need exhaust systems, they don't need transmissions, they don't need oil, they don't need gas. I could go on and on and on, all the things that electric vehicles don't need. Each of those is a major industry that is wiped out by these. So that's just one of hundreds of impacts. I don't know, Mark, if you have a knowledge of history. Have you heard of the Battle of Adrianople?
I have not, I have to be honest.
Okay. The Battle of Adrianople was fought in northern Greece between a Roman legion and the invading Visigoths who were invading the Roman Empire. It was the first major defeat of a Roman army to a barbarian army. This marked the beginning of the fall of the Roman Empire, right? So from then on, the empire was in decline. Now, the people in Rome didn't take it that seriously. They continued to go watch the gladiatorial combats, and they continued to discuss poetry in the forum, but they weren't even realizing that their empire was about to fall apart, right? Well, this is exactly the same situation here. We have a technology which some people have heard of, many people have not, and they think it's only designed to make little toys and cute little decorations and so on. Right? But in fact, it is a very, very serious technology that is growing very rapidly and is going to threaten many, many major industries. The car industry, for one. Like, for example, you may have heard of Local Motors, which now makes custom vehicles based on 3D printing. Right? And these vehicles are custom made for each customer. There's no way that GM or Ford can mimic that, can do that. Right? It takes them 6 months just to change a cup holder in one car. So how in the world could they make custom vehicles? They can't, right? And I can address hundreds of other industries that are going to be impacted by this. Now, the reason for us talking today is the housing industry. Well, we're working in our group to develop very large 3D printers that will be able to, using the same technology as the small printers, but scaled up 100,000 times, build entire structures. So you could build a house in 24 hours. And this house is stronger and better than any house you could build by hand. So, for example, in areas where there are hurricanes, this house would be much more resistant to hurricane force winds. In areas where there are earthquakes, these houses would be much more resistant to earthquake stresses. So you're getting my drift here, what's happening, right? And so think of that, building a house in 24 hours, ready for occupancy in 48 hours, because you can print the furniture and the drywall and the insulation, everything else all at once. And eventually we'll be able to print the electrical and the plumbing. Think of that, the entire house made in 24 hours. It's an awesome new technology. Now think of the jobs that it's threatening. You're eliminating all the concrete framer makers. You're eliminating the drywallers. You're eliminating the electricians, the plumbers. I could go on and on and on. And instead of taking 6 months to make a house, you're now making it in 24 hours. Think of the impacts of that. So we are at the leading edge of that. And it's not a question of if it will happen. It's a question of how quickly it's going to happen. It's already happening. Houses like this are being built in China all the time. We have a contract in India to build 20 million homes. Think about that, 20 million homes, right? And there's no other way you can build that many homes quickly with any other technology. So that is the situation on the ground right now.
You talk about 20 million homes. I would think that there must be some jobs and some skills required to do that in 3D printing, and some logistics to being able to make that many of them. You obviously need a lot of 3D printers.
Obviously, you have thousands of them working in parallel. But yeah, there are jobs setting up the 3D printer and supervising it as it works, continuing to supply a steady stream of concrete, which is the raw material, to the 3D printer, which is then pumped and then laid down layer by layer to form the house. So the jobs are mostly low-skilled technician job just to babysit the 3D printers, but everything else is done automatically.
The pictures that I have seen of some of these 3D printed houses, okay, they're small, they're obviously for, let's say, for design for the developing world? Is this something that eventually could print our suburban houses in the developed world, which are obviously a lot more materials and a lot more complex and a lot larger?
Definitely. Right now, there's an urgent need for housing in countries like India where they have millions of homeless people, right? And there's no other way that you can make housing quickly and cheaply as 3D printing does for homeless people. That's incredible. So in Vancouver here, we have quite a sizable homeless population, and we're now negotiating with the municipal government to build what's called laneway housing, tiny little 100 square foot or 200, 300 square foot houses, which can house one or two formerly homeless people. And like I said, these houses can be turned out like sausages in 24 hours cheaply, much, much cheaper than anything else. And it is a solution to homelessness, which I understand affects many American cities as well. So in terms of the suburban consumer, yes, 3D printer can build a beautiful estate. And this is now being explored. The Chinese have looked into this, of building luxury estates with 3D printing. We are going to be exploring this because we have a letter of intent to build a recreation area in India for the elite, because they want to get in on the scene as well. And we can build this recreational facility cheaper than any other way. And it's going to have large buildings which are designed to be beautiful and with architectural taste and designed for higher income people. Yeah, so the answer is yes, you can design beautiful higher scale houses much, much cheaper than it would take you to build any other way.
Just out of curiosity, what does Joom3D.com do in this space?
Okay, Joom3D.com is a company that I set up about 3 years ago, and its function was to develop a website which is called Joom3D.com, which was going to be a universal spare parts hub. So my idea is, when I was traveling in the developing world, everywhere I saw machines on the side of the road that were just abandoned, generators, motorcycles, so on, they're just abandoned. And I asked the locals, why those machines? It looks perfectly fine. Why are they abandoned? Oh, there's no spare parts for them. We cannot get the parts. And so that gave me an idea with 3D printing, especially with metal 3D printing, which is growing by leaps and bounds now. You can now manufacture any part for any machine if you have the design. So I developed this website to hold the designs for millions and millions of parts for all types of machines. So if you need a part for your coffee maker, your toaster, your motorcycle, your scooter, your car, right, you can now download them. This is already happening. We have a company in Vancouver here called Electromechanica, which is makes an electric vehicle for $11,000, a commuter vehicle. This is a breakthrough. I mean, compare that to the price of a Tesla, right, or to the GM Volt, or right, Chevy Volt. Sorry, this is a breakthrough. Anyway, they are not going to stock any spare parts at all. I have scanned in all their parts, and they're going to be put on our website. So when you need a part, you download it and you print it. So this is just on order. When you need something, you download it and print it. No inventory, no shipping cost. None of this other waste of money and resources. The most efficient way to supply spare parts to the world. And that was the purpose for Joom 3D. Now, as a secondary thing, we got into the printing of housing because the Indian government saw that this was a major breakthrough and could solve finally their homeless problem, which is infinitely larger than the United States homeless problem. And also we're now having wealthy people approaching us, like the investors wanting to make this recreational facility in India for the upper middle class in India. Well, they realize that we can outcompete any bid to build this facility because we can build it for 10% of the cost of a normal construction cost. So you can see how this is snowballing now into bigger and bigger things. You're going to start seeing recreational boats made by 3D printing, just like the U.S. Navy is now 3D printing their new battleships. The Gerald R. Ford is going to be the last of the conventionally built aircraft carriers. It's rumored to have cost $4 billion. Well, that's simply unsustainable. You can't keep building ships that are $4 billion ships. So the solution is to 3D print the ship for 10% of that cost. And you can get it done in a few weeks instead of years. So that is the future and is happening in every aspect of society right now. So people are going to wake up and they're going to see 3D printers everywhere. The Economist, which is not known to be an alarmist publication, recently said, anyone who thinks that there's going to be a 3D printer in every home is wrong. There is going to be a 3D printer in every room.
Very fascinating stuff. I'm going to play a little devil's advocate here for one last question, and that is, for any new technology with all the upside, there are some potential snags and downsides, and I can think of one in particular is that intellectual property, which has always been tough to protect content in the digital age, and of course the Chinese will knock off anything digital or otherwise. What about the problems of protecting IP in terms of designs with 3D printing?
Yeah, there's a general rule in IT which says information wants to be free, and that has been the trend. So, for example, we've seen iTunes, which found a solution which satisfied everybody, selling songs at 99 cents. They made the consumer happy because very few people are so cheap they won't afford 99 cents. And by giving payback to the authors of the songs and to the music companies, they were happy too. So they found a solution which met everyone's expectations. Now, in terms of objects, we're in a whole new world because the law simply did not conceive of objects being copyable. They saw songs, poetry, literature, art as being patentable or trademarked or protected as intellectual property, but they never foresaw that objects could be copied. And so right now there's a loophole in the law. There's actually no law preventing you from scanning in objects using a 3D scanner and then making copies of that object simply because the framers of the law did not foresee that was possible. So that hole will be plugged eventually, but right now it's a wild west. And that's why you have all over the world people with 3D scanners rushing to scan in all types of objects and statues and all types of things like that, because there's actually very few laws stopping that activity.
Paul, it sounds like 3D printing is going to have to transform more than just manufacturing.
Well, it's going to transform everything because I'm a hard person to surprise because I live, eat, and sleep this stuff every day. But I went to a conference a little while ago where a Russian researcher said with a straight face, we are a year away from being able to print out an entire human being. And I mean, people started laughing because they thought he was joking, but he wasn't. And then I put up my hand and I said, well, what would be in the brain of this human being? Because obviously you could print out the brain, but you can't print out the neural interconnections of the personality and character. And he said, well, we're working on that. But we could manufacture spare parts. In other words, body parts, biological body parts, livers, kidneys, hearts. So that means people no longer have to die sitting on a waiting list, waiting for a kidney, waiting for a heart, waiting for a liver, right? Because we'll be printing these organs as quickly as they're needed. So just think of the impacts that'll have on medicine. So when I talk on this subject, I bring up the inevitable problem of if people do not die because their organs are being replaced at the same rate as they're failing, you have a society with a problem because you have people who are going to 120, 130, 140 years old and are simply not dying. That could be a problem. So we have to restructure society to handle large numbers of people that live as long after retirement as they live before it.
And if you listen to my first couple of podcasts with David Wood on abolition of aging, obviously it's not a new issue. Well, Paul, I thank you for your time and interest, and I would love to get back to you in the future and talk more about bioprinting. But again, thanks for being with me.
Well, thank you, Mark. I really enjoyed this talk, and thanks for your interest in my work.
The 3D printing of entire human bodies is depicted in the HBO sci-fi series Westworld. Maybe it's not fiction anymore. I'll have more to say on the subject of bioprinting in a future episode of Seeking Delphi. In the news this week, several sources reported that the Russian Space Agency has begun recruiting cosmonauts for a lunar landing mission, which it projects to embark on in 2031, a mere 62 years after NASA's first manned landing. Ray Kurzweil has again updated his forecast on the arrival of the technological singularity, that point at which self-enhancing artificial intelligence explodes at breakneck pace and man and machine merge. He has previously set that point as somewhere in the 2030s or 2040s, but has now moved it forward to 2029, at which time he foresees the human neocortex being directly connected to the cloud. And finally, MIT Technology Review reports that the U.S. military wants its autonomous machines to explain themselves. Apparently, nobody understands exactly how they learn, think, and make decisions. Maybe they should try sending one to a shrink. A reminder that you can subscribe to Seeking Delphi on iTunes or YouTube and can follow us on Facebook. My thanks to Paul Tinari for today's interview. My technical assistant is Mohammed Marouf. The robotic cover art for Seeking Delphi is by Kai Stakoviak, and theme music is licensed from Pond 5. Thanks for joining me. Until next time, I'm Mark Sackler.